Okay, so today we're going to kind of go a little bit across the spectrum of capabilities that are actually in product right now. We've had a lot of great discussion about our overall strategy, the experiences that Nick talked about with our customers using our supervised learning AutoML capability, which we kind of look as part of the predictive AI portfolio. Over 150,000 models developed. And so I'm going to show both kind of a day in the life of how you use that platform, the no-code development, and then also just show some apps, like what can you actually do with it? What do we actually build? I'm going to speak a little bit to the generative AI work that's been done to date, and then maybe have these gentlemen speak a little bit more about the work that's being done to augment some of these capabilities. But what is so interesting about what I'm going to show you is that if we think about Qlik's customer base, the 40,000 plus customers, Qlik is the point where they're making decisions. Qlik is the place where they have all their data assets. And being able to combine generative capabilities with that is going to be very powerful in the business context. And then I'm going to bring it together a little bit, showing different integrations about how you can use our AI assistant with something like Teams to collaborate. And also key driver analysis, which is a new capability that is built on top of our predictive AI or supervised learning engine. As Nick was talking about, essentially what we're doing is we're taking, once we build an AI capability, we're infusing that across the entire workflow, from integration workflow through data management workflow, so that many people across the organization can use these capabilities. And the key driver analysis, which is built from explainability metrics within AutoML, is an example of that. The favorite part about my job is I'm working with customers every single day and across the spectrum, across the world. And the use cases are vast and we think incredibly impactful. Some of the organizations we work with, like ARH, are small. What was so cool about the ARH example is that that was a hospital system where they had no previous data science talent, and they couldn't afford to hire data science talent. In fact, if they're going to have any budgeting, they would probably get more people on the medical staff, more physicians, and they're able to build that capability themselves. On the other hand, we work with some of the largest banks, financial institutions of the world that have very large, robust, mature data science and machine learning practices, and they use our capabilities like AutoML as to accelerate a lot of the work that they're doing that's very complementary. And at the end of the day, and I love the question about the alerts, the way that I see it is not about building models. I think building a model is a technical point in the process. It's about building apps, about building capabilities, about delivering end user, delivering solutions that really matter to the end users. And so in sales, there's so many different examples, from like sales pipeline, customer churn, I'm going to talk about it today, marketing, understanding more about your customers, finance. We do a lot of work in the financial industry with both, in terms of I guess the finance domain, about like how do you have a better balance sheet and predict expenses, but also in the financial industry about the products they take to market and the risk, the overall expenses, what does it look like from a loan or an insurance product perspective. My favorite to work with is in manufacturing. There's so many amazing applications in manufacturing about yield, about being able to predict stuff into the future. And so then today, I know I'm taking up our demo time. I always do this. But I need to give you a perspective about what we're going to be looking at so you can kind of ground it. I'm going to go through a couple different end applications. The first one is I'm going to go through a day in the life about how to use AutoML to predict customer churn, building predictive applications with these what-if scenarios. So again, it's what do you actually do about it? One of the things when we work with customers is that it's not about finding the building the model, right? It's about that last mile delivery, in building it into a workflow where you can actually measure that. We call that the AI value capture. Second, I'm going to use generative AI integration with Bedrock to show how that works with the Qlik app in an operational use case. I'm going to use our AI assistant in Teams. I'm going to switch domains and pretend that I am in InfoSec and I'm managing all our securities and threats, which is not something I do in my day job, and I'm very thankful for those who do. But to understand, how do we actually use it in our workflow to interact with our data? And the last thing I'm going to do is I'm going to use key drivers to basically skip an enormous amount of steps in the investigative process and just understand what's happening with the data. So here I am, I'm in the Qlik workflow. And so I'm in the Qlik analytics application. I better look at a time check here. And so the first thing I'm going to do is I'm going to kind of show the day in the life of how do we actually build these models. And so this is someone who is basically going through the process of trying to understand, can I predict something about the future? And a little bit about this process flow is that it really starts with, and a lot of the conversation that was teed off earlier, if we think about what machine learning is that you start with a hypothesis. I think I can predict something about my customers. I think I might be able to understand what's happening all across my supply chain or in manufacturing or with my patients in a healthcare system. And then the second question is, do I have data where I can find potential signal? And that data, as Nick talked about, can come from everywhere. In reality, we see it from on-prem systems, cloud systems, CRM, Snowflake, Databricks, log data, session data, behavioral data, publicly available economic data. So it comes across this entire spectrum. And so the idea is, so how can I pull in this data and put this into, in a supervised learning perspective, a flat file, a machine learning ready data set, and investigate and see if there's any signal there. And then build those models and then deploy those into different sorts of applications. And so the journey that we're going to work on today starts with just an example of a flat file. And I know that this is a little bit hard to see because
it's data.
Yeah, we believe you that it's data.
You believe me that it's data. That's fantastic. So anyways, it's a structured labeled data set. And so I will say that there's work to get here, and I think that Nick talked about it. But essentially what you're doing is you're pulling lots of data, and Qlik has a lot of technologies that can kind of help with this process. But when I talk with customers, it's important to understand the information that you're working with for supervised learning. And I think that let's see here. Oh, you don't see, I'm looking at all of the screen, all of the picture here. And so there's essentially 3 different types of problems that AutoML can solve for these supervised learning use cases. There's binary classification, multi-class, and regression. So binary classification is any question that can be answered with a yes or no, which, by the way, is one of the most powerful questions in the business context. And in fact, we often advise our customers to start with a binary classification type problem. Will my customers churn in the next 6 months? Will my inventory stock out? Our retailers are all over that. It's so important for retailers to understand what their supply and demand inventory levels look like so they can match them. Otherwise, they have a lot of value at risk. There's multi-class questions. Which product will a customer purchase? Which subscription time best fits for the customer? And then there's regression, numerical. You may be more familiar with these, like forecasting or customer lifetime value, or how long will a patient stay within the hospital.
This is not really like object detection or things of that nature. I mean, there's a lot of the AI space that's just not that binary or multi-class kinds of things. I mean, are we talking vision systems? Can you go out and detect, whether it's a box, whether the Lego is properly proportioned and things like that?
Not in this type of AI. And so this is where, it's there are many different types of AI.
Oh yeah. No,
talk to folks, and so they're generative and predictive. This would be supervised learning. We do not do any. There's no image recognition or detection in this.
Okay.
Not yet. What we do, though, I'll tell you this, in the manufacturing field, so manufacturing data is one of the reasons why I love it so much is because it's really just kind of like raw sensor data, stuff coming off the field. And oftentimes it'll be, they'll ask us, like, can we use this image data? Not yet. But we can actually use features from that image data. And if you can basically put that into some sort of description, then we can use that. And that's where the machine learning becomes very valuable, because oftentimes we're talking about hundreds and hundreds of features and signals that people are trying to understand, what actually leads to a defect in manufacturing. And we'll be working with engineers that really understand their processes, but this machine learning can just sift through so much data and find patterns that you would never necessarily find. So the first step here is I will speak a little bit. I talked about the data connection here, but we've got at Qlik just so many different data sources to pull from, and sometimes it's there's the sexy and there's the non-sexy. I hope there's high SAP. There's a lot of just really important business data that we connect to, but the whole point is that we are agnostic to all sorts of different sources, which is really important in the data science process. I will say that we also connect to the generative services like Bedrock, which I'll show, and also OpenAI. But our journey starts in here in the Qlik catalog. So I'm just going to click Add New. So now I'm going into the day of the life of an analyst or someone who's trying to build a new experiment. And I'm going to call this tech. This is AI Tech Day.
Close enough.
Oh, it's close enough. Churn one. And so I'm going to go through a customer churn example. I can put this in a particular space. So in Qlik, it's we've got spaces as a way of doing access control, and so I've been playing around with a lot of different partitions, but I'm just going to keep this in my personal space for now. And I click create. So all I've done so far is just name and experiment. So the first thing I'm going to do is I'm going to select the data set that I'm going to use. So I'm in the Qlik catalog here, and you can see I've been playing with a whole bunch of different data sets. Some are owned by me, some are owned by my colleagues. We can have, you can upload Excel files, CSVs, Parquet files, and anything that's really a structured label, it's a good place to start. And I'm just going to select this churn train data set. And so the first thing it does is it pulls this into the platform. I'm going to zoom out here a little bit just so we can kind of see everything. And we do a lot of profiling, and this is where the automation kind of comes in. And that essentially behind the scenes, we're profiling it. In this particular case, I mentioned there are 3 different question types: regression, multi-class, and binary classification that we can solve for. The first thing that I need to do is just select the target. And a way to think about that is what is the variable that I want to learn more about? And so in this case, I'm going to select churn. And then in the background, we do a whole bunch of profiling here. And this is where we automate, using best practices, a lot of the data science process for you, so you don't necessarily have to. So what we've done here is that we've found a lot of insights about the data. Some of these rows we're going to drop because, for example, they're too highly cardinal. Other ones we do encoding, which is in machine learning, the machine learning world, there's a lot of pre-processing of data where you actually have to, take a string and convert that to a numeric so that the machines can do it. We just take care of that automatically for users. We also have an entire library of algorithms, as Nick talked about, and our data scientists are always vetting new algorithms to understand what is most useful for the particular problem at hand. Some of these algorithms are linear, some are nonlinear, some are 100 years old, some are relatively new. Our focus is not reinventing the wheel, using the best of breed algorithms and just making it very simple. And so, as Nick mentioned, especially in this, we want to run them all. I will mention, so I'm in the experimentation phase, and what the experimentation phase is, I'm trying to understand, based on my given data, will I be able to find any insights? In machine learning nomenclature, this is called training. It's very investigatory. It's very iterative. And because it's iterative, we allow for, in the Qlik platform, unlimited experimentation, because a lot of times you just don't know. Oftentimes I'll be doing an investigation with, working with a healthcare company in Florida, and trying to understand if you can predict stuff from their data. You don't know in the beginning, and it's very iterative. And we don't want to penalize that. And I'll say that that is a big differentiator between us and the compute-based platforms, that we just think it to be true to the analyst, be true to the data science process, we want to have unlimited experimentation. We also do a lot of, the pre-processing that I mentioned, and I'll call these best steps: imputation of nulls, encoding categorical features, feature scaling, normalization of data so you can kind of compare apples to apples, automatic holdout of training data, and 5-fold cross-validation. The simplest way to talk about these two is that we just want to make sure that we're fighting the general patterns and not overfitting within the data. So
these were configurations that you have pre-selected?
Pre-selected.
Yeah, so for instance, if we wanted to fix the nulls, that could be a process.
Yeah,
Yeah.
absolutely.
Yeah, okay.
Yeah, which is, that's a very good question. And so we have a customer in the insurance space,
Yeah.
and they had there was like sparse data where they would have too many nulls, and the feature was for a lawyer, right? And they want to understand what is driving the overall complexity of the claims. Every once in a while, there'd be a lawyer there, and so the first cut of this, it would say there's too many nulls.
Yeah.
But what we advise them to do is actually there's mostly other, and so there is a pre-processing step to do there. But absolutely, and that's sort of the process of thinking about how to do this data engineering that we're working with here. I will say that, as I mentioned, we work across the spectrum in that this is built for someone who has never had any experience in machine learning, just to go as fast as possible. When we're working with data scientists, they often look at this and they're like, this is just wonderful because it just takes care of all the work that I would have to do for supervised learning. And so a lot of the ways that the larger institutions that have very mature machine learning teams, they kind of think about AutoML, that it can offload most all of their supervised learning use cases. So essentially here, I've got to move my, now I'm just going to hit run experiment. And so this is an example of, now we're sending it to our cloud compute environment. So we have, basically, we have this very large distributed cluster for a lot of the machine learning tasks. In my previous life, when I'd be working with customers, we do a lot of this stuff on-prem, and it's very hard. It's hardcore. It requires an enormous amount of engineering and uptake. And what's nice about the Qlik environment is that we can just have everything run there, and we can iterate and move relatively fast here. And so this is actually a relatively large data set. And what we're doing is we're training everything. We're basically training every single algorithm against that data set. And what we're going to do is we're going to do a bake-off to see which one will have the best performance. And I actually just moved over to another example here, but it's the same data set. And after the data is run, essentially what we're doing is we're selecting the highest performing algorithm. And we're doing that based on our model metrics. F1 is the harmonic mean between precision and recall. And these are examples of metrics that data scientists and machine learning engineers will look at to try to fine-tune not only the performance of their data, but also understand kind of what the risk profile of the data will look like. We have a lot more model metrics than just those, but we basically try to be transparent and provide everything. We also show there's a question about hyperparameters. We show all the hyperparameters as well. I'll give you an example of some of the larger banks that we work with. They'll use this because you can move so fast and they'll be able to identify the right model for a particular problem. They'll be able to do the hyperparameter optimization to tune it. And then they actually want to recreate that exact same model in their own deployment infrastructure because they're a large bank and that's how they do it. But we're transparent and we show everything. What we also show are these explainability metrics. And this is really, really important because there's a lot of talk about trust. What explainability is, when we're talking about predictive analytics, there's two things that we're doing here. The first is we're predicting something about the future. Based on historical data, we want to predict something about the future. But the second thing is we want to understand why are we making that prediction. If we're gonna, if a customer is going to churn, we want to understand not just are they going to churn, but what are the reasons driving behind that. And if there's going to be a stock out or if there's going to be quality control problems on a manufacturing line, not only understanding is there going to be a problem, but what are the reasons driving it? Is it oil pressure? Is it temperature? What is it? Because that's what makes it actionable. And so for the two reasons, I just kind of got to the first one is number one, these explainability metrics make it actionable, but the second thing is they enable trust. And so a lot of the institutions that we're working with, they will actually require explainability metrics as part of for all their machine learning, because if they don't have that end-to-end visibility in terms of how decisions are made, they won't be able to trust them. And so we do that in two different ways. One is permutation importance and one is Shapley importance. We have a lot more literature on this, and I'm not going to get too deep on this just now for the sake of time. But Shapley values are based on game theory, and we calculate those on an event-by-event basis for every single prediction that we do to allow users to understand the specific reasons why we're making a prediction.
Just quickly on because it's obviously trained on your infrastructure.
Mm-hmm.
How's it licensed from a user perspective, and can you do unlimited model trainings, or is it capped, or you pay per hour or minute, or how does that kind of?
Yeah, so it's basically we have a tiered system, and so it's on the number of deployments. So it's a capacity-based pricing. And so right now that we do it when we work with an organization is that we'll cap the number of deployments, which would be the next step. It's like the deployed models that are in production. But anyone in an organization that has access to the SaaS platform could actually train these. We do have access controls so that if you're an administrator, you'll say, these are my data scientists. I only want them to be the ones that are able to train and do experiments. And for that subset of users, and that could be, it's up to the organization, it's unlimited experimentation.
Right.
So they can basically do as much as they want. And again, that's important because when you're investigating, you just don't know. A lot of times people ask me, they're like, well, at the start of like a proof of concept or something, I want you to guarantee that we're going to be able to find, whatever it is we're seeking. It's like, we just don't know. We're looking for predictive signal in the data.
So what I was looking for is like number of layers, number of nodes per layer, the learning rate, the activation function. Those are the sorts of things from a deep neural network perspective that are hyperparameters that are something an AutoML would experiment with. But I didn't see any of that here. It's focused on the statistical algorithms. I understand that, and I'm okay with that. But you know, it's not a deep learning neural network.
It's not a deep. So I'm gonna speak a little bit, and then I'm Nick, if you mind, I might have you speak a little bit to it as well. So the algorithms that we're not using neural networks, and the reason why we're not using the neural networks right now is for the explainability metrics. Is that it's really in my experience that it's very important to understand exactly why you're making these predictions. But there is a lot of there is talk about having some neural nets on the roadmap, and maybe I'll turn it over to you, Nick, to speak a little bit more about your thoughts on that.
Yeah, I mean, we're always looking for different ways in which we can get to better models faster. Neural nets in particular with structured data, supervised learning, they're not typically the right approach because they're not as transparent. They take long to train. They're more applicable, as we talked about in the generative AI space. So for that reason, we've elected to go with the other set of algorithms.
And you mentioned you have your own compute cloud. Is that where this stuff is running?
Correct.
Okay.
Correct. Again, taking another headache out of the equation for organizations where they don't have to worry about configuring that environment, maintaining that environment, and all that sort of stuff, where we've kind of done that at scale so that as bigger jobs come in, we can scale it to support that.
It's almost going to sound not true when I say this, but I've heard it enough, both from customers directly and with some of our partners that work with customers, that I'll share it. There are many circumstances where a data science team or organizations will be working on trying to build a model for over an entire year. And the complexities, doing it with Python, trying to understand where the infrastructure is going to be, build in the explainability metrics in that entire year span, they'll have basically gotten no results. And with this platform, they're able to do that in a day. And now I want to say that it's really use case specific, but being able to just take care of the compute, take care of the modeling, take care of making sure that for every single model we're building the Shapley values into them, that has been shown huge benefit for our customers, and that's why we've seen just such awesome adoption from it, frankly, with over 170,000 models run to date.
So if I'm hearing correctly, this time to value argument is that if I have a team of data experts, not necessarily data scientists, data experts who don't know anything about building infrastructure, models, etc. This is targeted them. I have the data, I know the results I want to get, but I don't have the infrastructure and the foundation to do that. This is a shortcut to that. Maybe the long way will get me better long-term results and capabilities, but this gets me there, like you said, in the day versus months or years.
Yeah, absolutely. That's a good way to think about it. And one of the other things that's important is that, it's all about building predictive apps. It's all about trying to understand how you can move the needle in the business. And when we're working with customers, so for example, in sales and customer churn, the goal is not, can I get a model that has 75% accuracy in predicting churn? That's not the goal. The goal is, with AI, can I build a strategy to increase net revenue retention by 3%? And so it's all about sort of focus on that end goal, because if you can do that, then that's when it really impacts the business. In your analogy, I think it's a good one, because one way that I like to talk to customers is that it's a very powerful calculator. You still have to understand what you're doing. You still have to understand the concepts. Division as a concept, it's actually relatively complicated. It's very hard to divide numbers in your head, but you know conceptually what you're doing. You use a calculator to do it. And so with this, understanding having fluency in machine learning and AI is important, and then this takes care of all the hard work. So just a couple, I'm going to try to round out the supervised learning AutoML piece just by showing an application here really quickly, and then I'm going to move on. But I do want to speak to the value of these explainability metrics, because they're powerful. So now this is an application that's built off the model that we just built. And what we show here are the different features that were within the data set. And so in this example, it was a subscriber business. We had a lot of different subscribers. They had accounts. We're charging them a certain amount. They've been with the company for a certain period of time. We have a certain plan type. And so let's look at the base fee, because that's a really interesting one. So we would think that if we start to charge a customer too much, they're going to get unhappy and they're going to leave. If we're not charging them enough, then we're leaving margin on the table. And so what we see here is on this horizontal axis, we see the base fee. And on the vertical axis, we see their likelihood to churn based on these Shapley values. And what we see is it's relatively flat up to around 35, 36 bucks, and then it sort of increases. And what's interesting about this is that this is a pattern in the data, hidden pattern around the price sensitivity. So we actually kind of start to see price sensitivity within the data here. We look at the plan type here. This is a little bit different. So the subscribers are on different plans. The red, yellow, green, the green, purple, blue, red plan. And what we see here, everything to the right of 0 is they're less happy. Everything to the left are more happy. And what we find is that there's actually a really bad plan. So we can actually take this much further and build this into some really powerful applications. And so this would be an example of an end user application for, let's call it a customer service agent, where they have a view of all the different, this is a pretty powerful application, but they have a view of all their different subscribers. And down here, I can basically flag, I've got to scroll out here a little bit here. I can flag whether or not I think they're going to churn. And what we see over here, I've got to strain your eyes a little bit more here, apologies, is that we have flagged a user that's going to churn. And we talked about this feature influence, those Shapley values, that we calculate that on a per account, a per row basis. So for this particular individual, I can select on that specific individual and understand what are the reasons that are driving their likelihood to churn. And I thought maybe it'd be about base fee. I had this whole long diatribe on base fee and price sensitivity and how amazing that is. It turns out it has nothing to do with it, that they're unhappy with their plan here. Okay, well, we've built this AI engine, we've deployed it. Now we can actually use what if scenarios. What if we were to change and experiment with, what if we were to change the plan type they're on? And actually, I can move them from the red plan here, this is a what if scenario, to a different plan. And what we see up here is the original projection, the likelihood to churn, and the scenario projection. I can put this as part of optimizations. We can build optimizations around these what if scenarios using our AI engine to start to understand and identify the sweet spots for particular users in a lot of different domains. And this is an example of churn, where here I can do a plan type by base fee optimization, where I can optimize for the likelihood to churn plus margin. And what we see, we work with a lot of customers that are super interested in pricing, and this is an example of how they can use machine learning and AI to help augment their pricing strategies, to use multiple AI models. Sometimes they'll chain these models together to do optimizations to identify based on what the math is telling them what the right pricing strategy is. So with that, I'm going to move over to, I'm going to change gears slightly. I'm going to move over to some of our generative demos. And to do so, it's going to be a little bit risky because I'm actually in Teams. And so this is an example of using our Insight Advisor. And what Insight Advisor is around being able to use natural language to ask things about your data. And what I think is very interesting, and I know that Ryan could probably speak to this for days, is that the analysts that we work with, analysts are still just a subset of users in an organization. People that actually want to kind of look in the data. Most people just want answers and results. And what we also, when our team was looking at how do actually people want to interact sometimes with data, oftentimes it's not going to a dashboard. It's using their own medium of choice. And so this is just an example of where we've integrated our Insight Advisor, our AI assistant, into Teams, where I can ask natural language questions and actually have that directed to all my different applications and interact with folks as well. And so in this particular example, I was saying that I'm in InfoSec, and so I can ask Qlik, show me, or let's see here, what were the incident accounts last year? So what were the incident counts last year? And then what that does is that runs a query to the right app. There's actually, I showed we've got a bunch of different apps that I have access to, but it has the context specific, it's context specific here, and it actually can, basically, query Qlik and then pull up the incident counts. And at the same time, I'm gonna, while this refreshes, oh, there we go. it's always just nervous, just nervous anguish. So what it did there is, Sean Stauth, your answer, incidents over the incident date. And then it's providing a lot of information about that. And so it's like, okay, it seems relatively spiky. I want to learn a little bit more about, okay, so what at Qlik, let's see here, at Qlik, Nick,
Yeah.
at Qlik, there we go. What are incidents by incident type? So I can go to that. And now it's going to start to deep dive a little bit more into this to provide even a little bit more information about the business.
Can you build upon previous questions without going to the Qlik dashboard, like context aware?
You can, and actually, I'm going to show that. I'm going to show that example. And so I'll kind of run through this, but now it's like incidents by incidents types, and what this is showing is that you've got insider threats, you've got ransomware, you've got phishing, you've got malware, all these sorts of things. And so now actually, I don't like phishing at all. So at Qlik, what were phishing? Can I spell this correctly? I don't want to get the band. Phishing counts last year. And I'll be able to get back, the numbers, and so I can dive deeper in here, and I'll show I can actually go directly to an app. So here we are. So it looks like here's our phishing incidents over time, and it looks like we have 2 spikes. So now where I'm going to say, at Nick, can you please investigate the spikes? And so now I'm in a medium where we can really work on it. You're gonna work on that, right? He's on it. Okay, fantastic. So explore it further. So yeah, I can. There's a suggested analysis where I can look at this. Basically it's all integrated right here. I can click explore further, and what that's going to do is that's going to take me directly into the application itself. And if I'm an analyst, I can start to look a little bit more deeper into it. I can look at the dashboards, incidents, the phishing attempts. But let's say that I just don't have time for this nonsense, and I want AI to do this kind of for me. I want to understand, well, what is actually driving these phishing attempts? Where is this actually coming from? So this is where the key driver analysis comes in, which is really cool. And so, as we mentioned, now that we have this AI engine there for and the Shapley values we talked about, we can actually take those and we can apply those to essentially any different feature and understand, well, what is actually driving something. So as an analyst, I don't have to go in there and do a lot of guesswork. I can actually just do it I can use AI to do it myself. And so I'm going into I just clicked on create a new key driver. And so the first thing I need to do, what is it that I want to learn more about? And now what I want to do is I want to understand, well, what actually could be driving these? So these are my humans. So essentially what is happening here is that, I have everyone in my organization, where they are, the age group, the state that they're in, the role type. These might be examples of where people who are trying to attack and get access to critical information. These might be examples of places where they're trying to attack. I might want to understand if they're a contractor, if they're new to the organization, if they're part-time, if that has anything to do with it. You know what I'm doing here? I got to tell you, I'm just guessing. I really have no idea. I'm just using, but then I can use AI to do it for me. And I click, start analysis here, oh, my analysis is already available. So it kind of ran through and it went through all the math for me. And now what it's going to do, it's going to say, okay, so based on the historical data from the phishing attempts, here are the characteristics that are likely to drive the phishing attempts. And so, actually state is very interesting. The state that the employees are in, the hire year, the age, aspects of the different age, the access, the contract. Let's look at that. Actually, access, that might be interesting. Yeah, different levels of access. And so, this is a demonstration, but the reason why I think it's really valuable is because it really allows you, it just shows what the math is doing and allows users to take the next best, most informed action. Okay, So now, of course, I'm moving a little bit quicker, but I do want to show, an example of the bedrock and the generative integration. And then I'm probably going to ask you guys to speak a little bit about how you kind of see this fitting in. But this is an example of, just an application within Qlik, and where we've built these bedrock connectors based on this contextual data so that we can use generative AI to surface the right kinds of insights. And in this particular application, I think that in the demo, they tried to build it so it looks pretty clunky. And so I'm an operations manager or a CEO, and I've got a whole bunch of data around my business. But I'm in the middle of a field day, and I just don't have time to explain everything to you. So instead, I'm just going to say, show me some insights on my data. And so I can do something like that. And so this is using Bedrock, and so it's all sorts of natural language questions. It is querying the internal data. It's going to be able to come back. You can't really see this here, but it's we've actually got a lot of information. The data contains open amounts. Industries with the largest total open amounts are healthcare, banking. Some industries are like oil and gas, and so I can use natural language. We can do this in French and German. I think 10 or more different languages are supportive. And I can say, which countries are most valuable or most significant. I'm choosing the hardest words to spell in the middle of a demo.
It'll get it right anyway. Right?
Significant for healthcare. We'll see if it works. This is a little bit of a live. Look at that. It's going for it. It's able to correct my mistakes in the middle of a live demo. Right, here we go. So this is so awesome. And so this is where, having this contextual data baked into, where someone is using it, but they can, most people in organizations really are not the analyst type. They want to be able to interact in natural language. And so this is an example of having Bedrock on top of our, contextual data. And so this is just the start. And so maybe if you guys have any thoughts on how this approach is going to be built in. And this is the end of my demonstration.
Yeah, I can speak to that a little bit. I mean, you can see here we're using, as I expressed before, natural language to expand who can engage with data analytics. Obviously, this is all working off of structured data that Qlik has a longstanding, leading edge technology in. But where we can start to expand this is, hey, I want to execute that query against a set of unstructured documents, where there might be other ways to answer the same question from from textual data versus structured data. So bringing that unstructured and structured content together in one user experience is, I think, a very powerful way that Qlik can, avail that for customers and really push the envelope on what can be generated with AI. So that's sort of where we see the vision here is if you're interacting with structured, unstructured data, like an analyst doesn't care. They just want answers that they can act on. And whether we source that from structured or unstructured data is where we're heading on that.
Do you think you'll bridge natural language queries on data, unstructured or structured or otherwise, through the triggers that we talked about earlier, like sending an SMS? They're like, hey, go gather the top 10 people likely to tune and send them a message saying there's a promo code or something running.
Yeah, so generate
those two.
Yeah, exactly. Again, we have that automation framework, so it's just a matter of building the blocks into that infrastructure where you can create a unstructured type of content that you would distribute. Similarly, you could get unstructured data coming in that creates a trigger to do something else, right? So I got somebody who does a form fill, and based on the form fill and all the unstructured text that's part of it, I can then ask a question against a knowledge base that then retrieves the right information, give them the right next action. So there's a lot of unique ways in which we can kind of go in between the different types of data sources there.
Are there any guardrails built in, especially since it sounds like one of the goals is to let some of the non-AI people that are more closer to the business to be able to create these algorithms? So are there any guardrails from accepting data, or if seeing, or if it presents data that is obviously bordering on breaking racial rules, like redlining or something like that? Is there any guardrails to say, this is what it brings back, but you should consider, this might be not a great way to go or something?
Yes, I can touch on that. So just in building generative solutions is kind of best practices in the enterprise is to put guardrails on top of these things. Excuse me, either to check whether or not they're hallucinating.
Yeah.
Because even if you put really rich content into an LLM, sometimes it just starts to go off track, and you want to double back and say, hey, this is the output. Can you confirm that, say, 90% of the words that are being generated are actually substantively similar to the input text? But then also on the stuff that you're talking about is any type of DEI type information that you want to, as an organization, maybe put some controls on, or just as a society we have controls on. So you can do that.
Yeah,
as
because
well.
there's historical data that is just not good. It
Yeah,
produces
totally.
really bad results.
Or
right?
That's what's key. This is what's key when I talk about building enterprise grade generative AI
Right.
solutions. Is if you just plug an LLM in, like it's going to be trained on all the information on the web, subreddits, all that
Right, right.
crazy stuff, and it's going to bring out that knowledge because it thinks, hey, like this is how humans act. But if you can actually use the power of an LLM, but bring contextual enterprise data to bear, then you can say, hey, I found this information. This is trusted enterprise content that our HR team, that our legal team, whatever looked at. I'm going to put it in, and I'm going to then double back when a generative answer comes out and say, make sure that it's confirming to the input data, which is already checked by a human. You're actually constraining the knowledge that's coming from an LLM, and you're solely generating that knowledge from the input content.
And that's what's built in here to Qlik then.
Yeah, well, that's what was built into Kindy, and that's what we're bringing into
Yeah,
Awesome.
Qlik.
yeah. So the stuff that, as I showed on that architecture slide, where Kindy fits in with the RAG architecture and answer management, is the ability to ask those questions, but have them rooted in a grounded source that you've sanctioned as being the source for answering that content. One of the things that Sean has stressed here, and we'll stress again with generative, is the ability to explain. Right. So even if you ask the question and you get a response back, you should always be able to source back to the source document, the source text that was used to derive the answer, so that you can again trust it. So that's applicable with what the stuff you saw in AutoML, just as applicable, if not more, with generative AI.
So I'm sorry, were you done? I didn't want to talk.
I'll go after you.
The follow-on question to that is, what happens when the answer create new bad data? So the answer becomes, I wasn't intending to redline, but now that I've asked the question, valid data, but the way that I asked the question, I'm now coming with a policy that creates redlining as a result of the data.
If you mind, I have some interesting. So that is that's the whole idea of trust, right? And so that's where having that data foundation. So we've got to think about there's the data, there's the algorithms, there's how they're used. And at each point of those, you've got to be able to have end-to-end transparency. So starting with the foundation, you've got to have the right data and have the trust, the lineage, the understanding exactly where that data came from. And oftentimes where people get into trouble is where they use derived data over derived data, so they actually cannot trace it back, right? You have to be able to trace that data back. That's where you have to have algorithms that support explainability too. So last week at a conference, there was the head of California's data science team was talking about how they cannot use algorithms that don't support explainability metrics, meaning they cannot even use neural networks. And the reason is because they have to have, for the algorithms they use, they have to be able to trace each decision back. And then, of course, it's like how they're actually used from a decision point of view as well, is that there has to be human in the loop, right? And until, to make sure that we really have the right ethics and the right trust with this stuff, there still has to be the right guardrails of human supervision of these algorithms so that you don't have like an ethical impact.
So I think, let me know if I'm wrong, if what we saw was we had the Kindy stuff. This was mostly a Kindy demonstration, all great. And the results of the AI questions and the answers were then presented using the traditional Qlik user experience. Is that what we saw?
Yeah, so just to be clear, so there's a couple different demonstrations.
Yeah,
I didn't
yeah.
want to confuse, but the last one was a generative.
Yeah.
And that was actually.
Oh yeah, I missed not the generative one, but
that was using Amazon Bedrock, but
Yeah,
that's exactly where something like Kindy would come into place.
yeah. So
Exactly.
right. So now my question is, if I think about Qlik before Kindy, can I use any of these features like in ingestion and data prep or would I use a traditional AI to enhance and augment data from the data sources before, the analytics were done on them.
Do you want to give that a shot?
Do you know what I'm asking?
Yeah.
Oh, yeah, repeat that maybe.
Okay.
Yeah.
So can I also use, use the AI portions, the generative, sorry, not the
data
generative,
processing and
the,
engineering stuff.
the first step, the statistical analysis,
AutoML, yeah.
well, after the AutoML's been done, can I, use an API or something to say, go tell me, like, I can't even think of all the demos I'm seeing. Like, can I send it off to say these customers that let's say we
Yeah.
bought a customer list. Can I now go predict, are they going to buy this product or not that product while I'm doing the data ingestion, the prep, and all the normal data pipeline things?
Yeah, so the typical workflow is you're going to use the data integration, the quality of that data
Yeah.
preparation to build that model and start using it.
Mhm.
Now, where you can start to use the generative side is now that I've got output coming from my predictive model,
Yeah.
how can I use generative to help me summarize or create actions or engage with that through natural language, which again opens up who can actually benefit from those insights. Because traditionally, data science teams take a model and then, they kind of put it out there and then people are expected to take action on it when it's not really set up in a form that they can use. Now, if we employ generative AI to help understand what a predictive model is telling them, then there's a more concrete action that they can use. So there's definitely interplay there. There's interplay on the opposite side where you can use generative to actually create and go through the process of building those models,
Yeah.
right? Which we were only starting to explore that capability. That would further expand who can engage with building.
That's
these
where the
machine-
Skynet part comes in.
Yeah. That's when we officially tick over.